Good afternoon, sir.
Good afternoon. Let's wait for 2 minutes. Then we'll start with the session. You can also keep with you the notebook and pen so that you can note down any point if you feel so. Okay. So all of you can put your attendance in chat box. You can type your roll number over there. Then I will start the lecture. Okay. Is it visible, the presentation?
Yes, sir.
Okay. So see here, we are starting with the module 1. It has two parts. One is kinetics of rigid bodies, where the concept of mass, moment of inertia and its applications are there. Work energy principle. Okay. So that part we will take later. We will start with the second part of the module 1, okay, which is based on basics of machines or basics of mechanism. Okay, we will come to that part later. So this part of the module, you can say it is titled as basic kinematics. Okay, so first of all, about the subject, what is in these subjects which is being offered to you at second year level. Okay, kinematics of machinery. So what we are going to learn in this subject, okay, as you know that it is a branch of science which deals with the motion and forces acting on the parts or links of a machine. You know that a machine or a mechanism is going to have different parts. We call those parts as kinematic links or element. Okay, so when a mechanism is transmitting the forces or is transmitting the energy, okay, that energy has to pass through the different links of the mechanism. So while bearing this load, okay, so what is the motion of any part, okay, which forces are acting on that part, we will study in this subject. Okay, so that is a brief discussion about KOM. Okay, so now let us start with very basic part of any machine or mechanism, which is nothing but it called as link or element. Okay, and if you want to precisely say it, it is called as kinematic link or element. So how to separate two different links of any mechanism? On what basis you will say that these two are separate links of the mechanism and they are not of one part, they are not the one link. Okay, so how it is defined? See, each part of a machine, okay, which moves relative to some other part is known as kinematic link. Getting this definition, what is the criteria here? That there should exist a relative motion between two parts. Okay, what is the relative motion? Okay, when some sort of distance, okay, some sort of distance is created between two links because of the motion, you can say that there is some relative motion. Okay, uh, just for example of relative motion, I will say, suppose it is one block, okay, say block 1, okay, and now I put another block for it. Okay, so what is happening here? See, one one block is there. Sorry for disturbance. One block is there, and another block is just put on that. Okay. Now suppose this, they are moving together, right? They are moving together. They go to the next position. Next position is like this. Again block 1, and then over which block 2 is there. So can we say, see, the position of both the block is changed. Okay, so can we say that relative motion happened between 1 and 2? See,
No.
the, yes, yes, answer please.
So between 1 and 2, there will be no motion.
Yes, correct. There is no motion between 1 and 2. So you cannot, you can say that part 1 and 2 are not separate part. We will consider them as a single one, right? Okay. So here, suppose if we are studying the KOM, okay, so we will say that 1 and 2 are not the separate links. We will consider them as a single link. Okay, so that is the criterion. That is relative motion should happen between two parts. Okay, for example, suppose next the condition is like this, that block 1 has come to this position, okay, and now block 2 is a little bit ahead of block 1. So definitely you can say that there is some motion happened between block 1 and 2. Okay, because earlier block 2 was on just right above the block 1, but now it is not there, means it has moved with respect to 1 also. So you can say that now they are behaving separately. and these are two different parts, 1 and 2. So here relative motion is detected. Okay, so that is the very basic criteria to identify the separate links. Okay, for again, suppose there are two different links like this. It is one link, here is one joint, you can say one joint, and to that joint another link is connected like this. Okay, so if you consider the motion, say it is link 1 and it is link 2. If you consider, if you observe the motion of this particular arrangement, link 1 and 2, and you observe that after some time it happens that link 1 is at this place. Okay, it is a joint here, and link 2 is somewhere here. Okay, so by looking at the angle between them, earlier what was the angle, now what is the angle, you can say that relative motion is happening or not. What you can say? Yes, see the position of 1 and 2 with respect to each other has been changed. The angle has increased. Angle has increased. So you can say that 1 and 2 are two different parts, two separate links. They are not the single link. Okay, here movement, relative motion is what? Here relative motion is angular movement. Are you getting?
Yes, sir.
Okay, so it is very basic criteria, please understand. Okay, and with the help of this concept, you can count the how many links are there in one mechanism. Okay, and this number, that number of links, okay, decide so many factors. Depending on this number you will calculate many things in your further topics. Okay, so it is very essential to understand this concept. Okay, so it is the definition of kinematic link or kinematic element. Now next is a link should be a resistant body. What is the meaning of resistant body? Okay, so resistant body is one, okay, which does not deform in a way to affect the motion transmission. Okay, so suppose if on any link a force is acting and it gets deformed on application of that force. So if it gets deformed, it will not be able to transmit the force to the next link. Okay, getting this? So a link should be a resistant body. Okay, in a way that motion transmission is not affected. Okay, when you will study further, you will find out that there are some flexible link, means link can deform while transmitting the motion, but it does not affect the transmission of motion, like in case of belt drive, chain drive. So this chain is used to transmit motion or power from one part to another part. Okay, and in this process it also gets deformed. It is flexible, but it does not affect the transmission of motion, so we can consider that chain as the resistant one. Okay, it is not deforming in an uh, unuseful way. Okay, so let us move to the next then. Okay, okay, this yes, this mechanism, let us understand. So see how this mechanism work. Okay, and how many different links are there. So you can say that this is the piston, this part is the piston, Okay, and this piston slides in this guide, which is called as piston guides. Okay, so as this piston has motion with respect to the engine frame, okay, it is piston or cylinder is a separate part. Then this piston is connected to this connecting rod. Okay, this is the connecting rod. So what will happen when this piston will slide? This connecting rod and piston has joint here. Okay, so as it will move forward, so this connecting rod will make some angle with respect to the piston's horizontal position. It will increase. This angle will increase. In the result, the connecting rod connecting rod just a second. uh, Sorry for disturbance. Yes. Okay, so are we back? Okay, so see what is happening. This uh, connecting rod will rotate like this around this point. Okay, so as it is making some angle with respect to piston, you can say that connecting rod is a separate link. Okay, then again here connecting rod is joined with crank. Okay, as in operation, the crank will keep rotating. Okay, like this, and this point, this particular joint will move in the circle. So looking or observing the motion of these two, that is crank and connecting rod, you will find that angle will keep changing between these two links. Okay, so you can say that connecting rod is separate, crank is a separate link. Okay, then again, crank is connected to the crankshaft. Okay, okay, and crankshaft, they both rotate with same angle. So you can't say that crank is different link and crankshaft is different link, because both are rotating simultaneously. There is no any change in angle. Okay, whatever is the angle of crank, that is the angle rotated by the crankshaft. So crank and crankshaft is be considered as one link. And this crankshaft is supported in this bearing, which is provided in engine frame. This bearing is stationary, right? This bearing is stationary, and crankshaft rotates in that. So crank is a separate part and bearing is a separate part, because there is some motion happening. Okay, so like that, if you count from piston, then you will say that this mechanism is having four links: piston, connecting rod, crank, and engine frame. This is completely engine frame, which is stationary. All stationary part is only one single link. Okay, because if you consider engine frame here and here, after some time they will not be changing their position with respect to each other. So engine frame is a single link. Okay, and how this piston is operating, it is reciprocating because of this cylinder and piston arrangement. So what is happening here, in case of steam engine, a hot and high pressure steam is entering into the cylinder, and that steam will exert the pressure over here. Okay, and because of that pressure, this piston will move. As it will move in the cylinder, it will slide the piston outside the cylinder like this. And that's why this is how the motion of piston will take place. Are you getting it, how I identified the different parts of the mechanism? Okay, mechanism
Yes,
is
sure.
the skeleton of any machine. Okay, a machine consist of a single mechanism or many mechanism. Now let's move to the next slide. So types of link now. Link is the element which takes force from another link and transmit it to the some other link, some third link. Okay. So motion is passed link to link. So it has different types. Okay. Depending on whether deformation of it takes place or not. So first is rigid link. Rigid link is what? It does not undergo any deformation while transmitting motion. Okay, so you just apply motion of force on one side of the link and it will transmit that force to the another link. Okay, if you see in a strict sense, rigid link does not exist in a strict sense, because you know that if you will apply some force on some component, okay, so that component is going to deform. Okay, though that deformation will be very negligible. Okay, but deformation will be there. Okay, as deformation in rigid links is very negligible. Okay, we consider that there is no any deformation. Examples are connecting rod, crank, etc. All these links are made of metals. Okay, and their deformation is very negligible, so they can be considered as rigid link. Next is flexible link. What is flexible link? It is partly deformed in a manner not to affect the transmission of motion. It deforms means, for example, if you consider the belts, okay, so what this belts does, that when they transmit the motion from one pulley to another pulley, okay, so there some deformation takes place of this belt, means sometimes they get elongated. Again I feel coffee. Okay, sorry again, sorry for disturbance. Okay, where were we? uh, Flexible link. So this link will deform, okay, but it will not affect the transmission of motion. Examples are your belts, ropes, and chains, etc. Next is your fluid link. Okay, so what is a fluid link? It is formed by having a fluid in a receptacle. Okay, means receptacle is nothing but your cylinder, you can say, and the motion is transmitted through the fluid by pressure or compression compression only. Okay, so what is done, there is one cylinder or receptacle of the fluid. Okay, and this fluid is under very high pressure. It is going to force that piston. Okay, and this force will be transmitted through the fluid. What are the examples? In hydraulic presses, you use the oil pressure in order to operate different parts of the hydraulic press. Then jacks, which is used to lift the heavy vehicles. Okay, and brakes. So you know that even brakes have become hydraulic brakes. Okay, So in case of operating the hydraulic brakes, you will need a very little force. And why that little force is required? Only to turn on the uh, high pressure fluid into the cylinder. That valve, to operate that valve, once it comes, it does the braking. Okay, so example of the fluid link, we can go to the previous slide. See here, piston and cylinder arrangement is there. So here high pressure steam will enter. That steam is nothing but a fluid. Okay, and because of its pressure or compression, okay, it will push the piston. Okay, this piston will be pushed, and the force will be transmitted to the piston which is outside, and this way this engine will work. So here the link is nothing but your fluid link. Okay, so these are the example of types of links. It is the example of rigid link. Okay, then it is the connecting rod which is connected to the piston. Okay, this rod can have angular motion here like that. So actually these are two separate links. It is the piston, and this one is the cylinder. Next is your kinematic pair. Now you have seen what is kinematic link. Okay, so what is now kinematic pair? Pair means two things make the pair. Okay, so how you define the kinematic pair? When the two links or elements of a machine, when they are in contact with each other, are said to form a pair. Okay, means there should be contact between two elements. Okay, as we have seen the piston and connecting rod. Okay, they have the contact at one end. Okay, and the relative motion between them is completely or successfully constrained. Okay, so the relative motion between them should take place. Okay, if relative motion is not taking place between them, so we do not consider them as separate links. Okay, so relative motion is there between two links, and that relative motion is constrained motion. Okay, what is the meaning of constrained motion? That motion takes place in a definite direction. Okay, in a predicted direction. Okay, you know that when these two links will be there, only this motion is possible between them, and no other motion is possible. Okay, that direction is known to us. The pair is known as kinematic pair. Okay, so here there are two concepts that they should be in contact with each other. Two links which form the pair should be in contact with each other, and whatever relative motion is between them, it should be constrained motion. Okay, for example, now I will explain you what is the constrained motion. Suppose it is one flat surface, right? And I am assuming that it is fixed. Okay, this is the symbol of fixed. Now over it, let us consider only the planar motion. Okay, over which a block is kept. Okay, now what? Okay, So if we go out of time, please join back. A block is kept, right? Now what will happen? Suppose if I apply the force in this direction. So where will be the motion of this block? Okay, along the fixed path, right? Along the fixed path means you are knowing the direction of motion. Okay, but suppose if somewhat I incline the force like this, if I apply the inclined force like this, then where will be the motion of the block? In which direction the block will move? Okay, so chances are what? Chances are there that this block may lose the contact with the ground. Okay, and it can also move in any other direction like this, etc. Okay, because it is not constrained, it is not restricted to move only in the x direction. It can move. If I want to restrict its motion, okay, so what I will do, I will provide a recess or a guide. Okay, now I have completely blocked the motion of the piston or motion of the block in any other direction. Whenever it will try to move in this direction, this surface will stop it, right? Okay, and now block, you can say that this block is constrained to move only in the x direction and not in any other direction. So you can say that the motion of the block is constraint motion. Okay, and if an object can move indefinitely, okay, its direction is not fixed, then you say that it is having a unconstrained motion. Its motion is not restricted one. Okay, so in mechanism we find that only the constrained motion is useful. Okay, unconstrained motion is not useful in mechanisms or machines. Okay, got the meaning of constraint?
Yes, sir.
Okay, so the example you see of the steam engine, okay, now you can see that how many kinematic pairs are there. Okay, so I will again go back with that to that slide. See, it is the piston and connecting rod connected here. Okay, they are connected here. Okay, and sorry, what kind of motion is possible between them? That is angular motion like this. Okay, and not any other motion. It can have only the angular motion. It will not happen that this connecting rod will slide with respect to the piston, that it will this point will change. Connecting rod will be somewhere here and piston will be here. No, only what kind of motion is possible? Angular motion only. So angular motion only in one direction, that is about this axis, is a constrained motion. Okay, so you can say that it is a kinematic pair. What is, and that kinematic pair consists of piston and your connecting rod. These two links are connected to each other, right? They have the joint here, so they form one kinematic pair. Okay, then other examples. Okay, here. Okay, so you can see that this cross head or piston or block is connected to the frame. They are in contact with each other, right? They are in contact, cross head and engine frame, they are in contact with each other. Now what kind of motion is possible between them? Only reciprocating, means the motion is constrained. So you can say that it is another kinematic pair, and this kinematic pair consists of cross head and engine frame. It is one kinematic pair. Second kinematic pair we have seen that piston and connecting rod. Second kinematic pair. Third third is again which two parts are connected together? Connecting rod and crank. They are connected at this point. They are in contact, and the motion between them is again constrained. Only angular motion is possible between them. So I will say it is the third kinematic pair, connecting rod and crank. And next, crank and crankshaft. It is one unit only, one link, because they both rotate simultaneously with same angle. So crank, sorry, it's ache in my ear. Okay, I will keep it here. So here, crank, there is a connection of crankshaft and this engine frame, right? And what is the motion possible between them is that this crankshaft is rotating with respect to engine frame. Okay, this rotation is again constrained motion because only rotating is happening. Sliding is not happening between crankshaft and engine frame. So I will say that this is another kinematic pair. Okay, so now you understand the requirements for forming a kinematic pair. First, that these two kinematic links should be in contact. Second is that they should have constant relative motion between them. So they we will call them as kinematic pair. Okay. So let us move to the next. So next we will discuss what is the constraint motion. Okay, here you can see that two words are used: completely constrained or successfully constrained motion. So we will see that. So see, it is the types of constrained motions. Okay, first one is completely constrained motion. Okay, so what is it? Let us see the definition. When the motion between a pair is limited to a definite direction, okay, irrespective of the direction of force applied, then the motion is said to be a completely constrained motion. Okay, so examples are of the piston and cylinder. We have seen that the motion between piston and cylinder is of sliding motion. That piston can only slide in the cylinder. Piston will not turn about any axis. Okay, so the motion between them is completely constrained. Another example you can see, it is a square block with hole. Okay, and in that square hole you have the square bar in that. Okay, so you try to apply the force in any direction. Okay, but the square bar will move only in the linear direction. It is successfully constrained. It cannot move in any other direction, and even it cannot turn about any other axis. Okay, so you can say that square bar is completely constrained in the square hole. Here, see, a shaft is rotating, okay, in a circular hole. So shaft can only rotate. It can only rotate. But whenever the shaft will try to slide, okay, uh, when the shaft will try to slide in this direction, okay, what will happen? This collar is provided to stop the axial movement of the shaft. Okay, so axial movement is not permitted because you have some prevented it